Okay, there we go. Now it's working. All right. Today we are talking about the substitution method. Notice we still have two equations with two unknowns. It's called a linear system. We learned graphing. So you graph each one individually and the intersection is the answer. Then we learned the elimination method where you add the equations together and eliminate a variable. Now we're going to use the substitution method. So these are three methods to do the same thing. We're just going to run through some of these quickly. Should be really easy, and that'll be it. So this should be a quick one. So with the substitution method, you need one of the variables solved completely. So this means my y is isolated, so this one is good. What I'm going to do is I'm going to look at the other equation. So I'm going to do this in blue. I'm going to write x plus 2. Now instead of y, so instead of this y, I'm going to put this, because the top equation tells me that y is equal to 3x plus 2. So two things that are equal to each other are interchangeable. Equals 11. So notice again, I have x plus 2y, but instead of y, I wrote 3x plus 2 equals 11. So I wrote the second equation and substituted the first equation into it. So now I'm going to solve this. I have one variable. My first step is going to do the distributive property. Whoops, that's not 2. That's 2 times 3, which is 6x, plus 4 equals 11. Now I have x plus 6x is 7x. Combine my like terms. Plus 4 equals 11. Now I subtract 4 from each side. 7x equals 7. Divide by 7. X equals 1. Now what I'm going to do is, I have x equals 1, but you remember from last class, that was only half of my answer. I have x equals 1 comma something for y. Now in substitution, you could use either equation, like an elimination, to plug back in, but there's one that's clearly the easier one, and that's going to be this one, the one that's already solved for y. So imagine I replace this x with 1. I get 3 times 1 is 3 plus 2 is 5. I could use the other equation, but it would just be more work. So my answer is 1, 5. It's the only point that's going to solve both equations. Let's go to the next slide where we can write in the steps. So if you have any trouble, you can go back and look at these steps. And notice that neither one of our equations is solved for x or y the way it was in the first one. So these are the ones we're going to have to get used to. So our first step is solve for one variable. Well, I have an x, a y, and a y. Only one of them has a coefficient of 1. That's this one. That's the easiest one to solve for. So I'm going to add 2y to both sides. And that equation becomes x equals -6 plus 2y. That's my substitution equation. So my step 2, substitute this expression into the other equation. So if I look at this equation, I'm going to rewrite this, but instead of writing this x, I'm going to replace it with -6 plus 2y. Then I'm going to keep going. I'm going to write 6y equals 4. Step 3 tells me to solve this new equation. So we're going to use methods that we learned before. The first step is usually the distributive property, because when we substitute, we want to make sure we put parentheses. So 4 times -6 is -24, plus 8y plus 6y equals 4. And let's keep going. Combine like terms. 8y, so I get -24. 8y plus 6y is 14y. Now 14y, it's important. So now I add 24 to both sides. I get 14y equals 28. Divide by 14. And y is equal to 2. So I did that. But there's still 2 more steps. So this is the part where a lot of times we're like, oh, I just solved the equation, I got y, I must be done. But no, there's 2 more steps. Step 4 is to substitute the answer from step 3 into one of the original equations. Now, we got y equal to 4. Or sorry, y equal to 2. And we got y equals to 2. So I'm going to take that 2 and I'm going to plug it in for y. So what I get is x equals -6 plus 2 times 2. That's 4. 4 plus -6 is -2. So my answer is -2, 2. And that is actually my 5th step, which I skipped ahead to. Give the answer in the form x comma y. So you're not finished until you have both x and y and you put it in coordinate form. All right, so let's move on. Let's just try a couple examples and then we'll be done. Notice this one. So I'm going to go through 3 levels of problems. This is our easiest type of problem. What we have is y equals 2x plus 5. Y is already solved for, so I'm going to look at the other equation. I'm going to rewrite it as 3x plus, instead of y, I'm going to write 2x plus 5, because that's what y equals, and I have equals 10. Now this one, notice I don't have to distribute because this was just y. The coefficient was 1. So I have no number to distribute. You can distribute a 1, but anything times 1 is itself. So I can go right to the combining like terms part. 3x plus 2x is 5x, plus 5 equals 10. Subtract 5 from each side. 5x equals 5. Divide by 5. X equals 1. Then I go back up, and I got x equals 1, and I'm going to look at this equation that says y equals 2. Now I know x is 1 plus 5. 2 times 1 is 2 plus 5 is 7. So my answer is 1, 7. And that is it. So let's go on to another example. This one, we get x minus y equals 3 and x plus 2y is equal to -6. There's several things we could do here. I think the easiest thing is we solve for this x. We could solve for this x or this y. I would stay away from this y because of the negative in front of it, and I would stay away from this y because of the 2 in front of it. So I'm going to solve for the initial x by adding y to both sides. So my substitution equation is x equals 3 plus y. Then I'm going to go and I'm going to rewrite my other equation. Don't plug it into the same equation that you used. Plug it into the other equation. So instead of this x, I'm going to write 3 plus y plus 2y equals -6. Now again, since I plugged it into something with a coefficient of 1, there's no reason to use the distributive property. I can really just ignore the parentheses. The only reason I put them there is just to be safe. It's always easy to put it in as parentheses so you remember to distribute. But when you don't have to distribute, you can ignore them. So I'm going to combine y and 2y. So I get 3 plus 3y equals -6. Subtract 3. 3y equals -9. Divide by 3. And I get y equals -3. So I know my answer is something comma -3. Now how do I find that x? I'm going to plug -3 into here, the equation that it's already solved for. And 3 plus -3 is 0. So that's my answer. All right, moving on to the last problem. Now what we have here is 3x, -2x, 4y, and y. There's one there that's clearly the easiest to solve for, and that's going to be this y. So you want to look for a coefficient of +1, and that's going to make it easier on yourself. We could solve for the other ones, but it would just be more work. So what we have is, if I subtract 3x from both sides, I have y equals -7 minus 3x. Now I'm going to go down to my second equation. Remember the other equation, 2x plus 4 times y, but instead of y, I'm going to write -7 minus 3x. This equals 0. Now notice, I have a 4 in front of what I'm substituting, and this 4 here, I'm going to have to distribute now. So that is not plus. Positive times a negative is a negative, so I have -28 minus 12x equals 0. Now I'm going to combine like terms. These are on the same side, so I need to combine those. That's negative 2x plus negative 12x, so negative 14x minus 28 equals 0. I'm going to add 28 to both sides. So I end up with negative 14x equals 28. Divide by negative 14. X equals negative 2. So that tells me my answer is negative 2, comma, some y value. What I'm going to do is take that negative 2 and I'm going to plug it in to this x. So y equals negative 7 minus 3 times negative 2. Be very careful. Negative 3 times negative 2 is positive 6, so I get negative 7 plus 6, which is equal to negative 1. So that's my answer. The only other thing that I would like to go over right before we end this video is the special cases, because we don't have a problem like that. But what we will do, we will have some of those in class, so we'll talk about those more. But what you want to do, if you ever solve a problem and all the variables go away, so we talked about this in the elimination video. The same thing applies for substitution. If we do a bunch of steps and then we end up getting 0 equals 0, if that ever happens, your answer is infinite solutions. If you ever do a bunch of work and you end up with something like 2 equals 0, which doesn't make any sense, you get no solution. All right, so that can still happen in the substitution method. I just didn't do an example of that. We will see plenty of those in class on Monday. All right, so that's it for today. Nice quick video. I hope everybody has a good weekend, and I will see you on Monday.